Hello viewers, welcome to Big Boy Physics. In today's video, I brought you up a problem. I have taken it from DJ Griffiths. Okay. Now this problem is basically related to JEE Advanced and involves a bit of vector and all those understandings. Okay. This question is based on the topic of electrostatics, and as usual, I'd like you to give it a try for a few minutes, then see the solution. Okay. So let's get started. Okay, so I have taken a pressure diagram, and before going through this problem you must know few theorems. First is that if a dipole is placed in certain electric field, then the interaction energy between the dipole and the electric field is given as minus p dot e. P is the vector of the dipole and E is the vector of electric field. Okay. Now, for few deductions from this formula are that if p vector and e vector are parallel, this implies that the configuration is in the most stable possible state. Yeah, because when p vector and e vector are parallel, this implies that positive charge of the dipole. We can represent the dipole as a separation of positive and negative charge. Observe that this positive charge will be pulled away by the dipole electric field, and the negative charge will be pulled away by the electric field. Okay. So I hope you get it. This is the basic formula you can see at HC Burma. Okay. For those who haven't done electrostatics yet, you can skip this video. It's not for you. Just wait for your topic. I'm especially talking about 11th graders. Okay. So yeah, one thing I say that the potential energy between the electric field and the dipole is given like this. Now assume that this electric field is created by a infinite sheet, the infinite uniformly charged set, better to say. Infinite uniformly charged sheet actually basically creates this electric field, and due to this, it affects the potential energy of the dipole. So we can say this energy to be the interaction energy between the dipole and the charged sheet. So this is one of the observation we'll be using in this problem. And second thing you must know about dipole is that the electric field due to dipole. Suppose a dipole lies somewhere here. Then on the radial axis, if I take a point at a distance r, the electric field is given as 2 kp by r cube. Similarly, if I take a point on the angle bisector, then I can say that the electric field will be opposite direction to that of dipole's vector, which will be kp by r cube. So vectorially we can represent this electric field as a 2 kp vector by r cube. So this basically represents the electric field along the radial direction plus kp if it is a radial direction, and the tangential direction I can say e theta is equals to minus kp vector by r cube. Okay, so these are other two important things you must remember. Now suppose instead of talking about radial or the point along the bisector, I consider another general point. I consider a general point, suppose this point to be O. Now let this point to be O and this point to be somewhat Q. And this angle represents theta. Now I will be representing this line joining OQ vector as R vector. So I can resolve this P vector into two components. One will be P dot r cap, P vector dot r cap, where r cap basically represents the unit vector connecting O and Q. Similarly, I will be resolving this P vector in the theta direction as P vector minus P vector dot r cap dot into r cap. Okay, this r cap will basically give me the direction of the electric field, or the basically give the direction of the dipole moment. Okay, now using this resolution and then putting the values, all those will be getting the answer. Now coming to the problem, I am taking the diagram again. Yeah, so this is my diagram and this represents the r vector. So I can say that the unit vector connecting the center of the dipoles represents the r cap direction. Now the time is to resolve the p vector, p1 vector. Let us resolve the p1 vector. So I can say that this side represents p1 vector dot r cap along r cap direction, and the perpendicular one I can represent it as a p vector minus p vector dot r cap along the r cap direction. So I can say that electric field and r vector can be represented as 2k p1 vector dot r cap along the r cap direction upon r cube, where r represents the distance between the center of the dipoles. Okay, so this is the first. Now the electric field due to the second one, that is the perpendicular component, will come out to be minus k p vector minus p vector dot r cap along the r cap direction upon r cube. Hence, if I write the expression, I'll get the answer to be k by r cube into 3 p1 vector dot r cap minus p vector. Okay, it's p1 vector rather. Sorry. Okay, so this is the electric field due to this dipole at a distance r vector. Okay. Now we know that the interaction energy is due to the interaction of the electric field with the dipole. Now this electric field is created by P1 vector. Hence I can say that the interaction energy between P1 and P2 is the electric field due to P1 dot P2 vector with a negative sign. Right? Now just we are interested in the dot product, just put the values k by r cube P1 dot P2 vector minus 3 p1 dot r cap whole dot p2. Hence my final answer will come out to be k by r cube p1 dot p2 minus 3 p1 dot r cap into p2 dot r cap, and that's the final answer. Okay, so yeah, this is somewhat an interesting and nice formula. This formula actually was given in one of the INPSO previous papers, and they asked you to evaluate few things. Okay, though probably they didn't ask you to derive it, but in this video I provide you a detailed derivation of the whole formula. Well, it involved a bit of high level mathematics and a little bit of vector algebra, nothing else. So hope you get it. So one thing to say, that is thank you, have a nice day. If you enjoyed this video, don't forget to like it. So stay safe, uh, have the fuel in your hard work. Bye bye.